Every fatal crash begins with a specific physical reality, a distraction, a sound, and the violent transfer of kinetic energy tearing through steel and glass. By the early 1970s, as the American highway system rapidly expanded, the physical toll of that energy became a national crisis. Traffic fatalities surged past 50,000 deaths every single year. But the federal government had a massive blind spot. When investigators arrived at these scattered, violent scenes, they documented the wreckage using thousands of different, incompatible local police and medical examiner forms. There was no unified language to capture what went wrong. Without a way to measure the specific causes behind a tragedy, engineering a solution was impossible. Lawmakers and automakers were operating entirely in the dark. To fix this, the National Highway Traffic Safety Administration, or NHTSA, issued a federal mandate. They built the Fatality Analysis Reporting System, commonly known as FARS. NHTSA designed FARS as a forensic-level standardized database. It was built to capture the exact, verifiable truth behind every single fatal crash on American highways. The system provided the mechanism to transform the unpredictable chaos of the road into structured, immutable code. To turn that chaos into clarity, the system organizes information into 5 core tables: accident, vehicle, person, roadway, and environment. Because this is a relational database, these tables are linked by primary keys. ST-case serves as the unique identifier that maps variables from every table to a single specific crash event. Then a temporal key called ACC year stabilizes the record. This strict timestamping allows researchers to pull a query from 1985, compare it directly to a crash from 2025, and know the data parameters remain consistent. The schema captures hundreds of intensely granular details. It records the roadway conditions, the ambient lighting, specific driver decisions, and whether mechanical safety systems activated or failed. Every input is governed by thousands of pages of coding manuals. These texts explicitly define every allowed numeric value and enforce strict validation rules to keep the data perfectly clean. By enforcing this rigid architecture across millions of isolated incidents, investigators can isolate the variables that dictate whether a passenger survives. The ingestion pipeline begins on the asphalt. Police officers, medical examiners, and crash reconstructionists gather the raw physical evidence from the wreckage. Those details are then handed off to highly trained state analysts. These individuals act as the translators between the twisted metal and the digital database. They take qualitative materials, hand-drawn diagrams, witness statements, and toxicology reports, and convert them into specific numeric codes. It is a brutal extraction and transformation process. A human life becomes a record. That record becomes a row, and that row becomes a statistic. Once compiled, NHTSA distributes this validated dataset to the public every year. They maintain legacy formats, publishing SAS datasets, CSVs, and fixed-width text files, but they also expose the data through a modern API. This interface allows developers to pull records in JSON or XML format directly from a structured Postgres backend, a robust database system designed for complex queries. Whether a researcher pulls a modern API request or parses a 1990s text file, the system executes the same goal, delivering meticulously validated truth, prioritizing accuracy over speed. The datasets generated by FARS directly produce the safety policies governing modern transit. When researchers queried decades of frontal collision metrics, the evidence forced the automotive industry to install standardized airbags in every vehicle. By tracking the specific vulnerabilities of infants and toddlers in crashes, the data directly drove the evolution and strict enforcement of mandatory child safety seats. And as the database clearly linked alcohol concentration to fatal outcomes, lawmakers used those undeniable trends to aggressively tighten national drunk driving legislation. Because FARS makes the specific causes of death measurable across millions of instances, it forces continuous iteration in both vehicle engineering and public policy. The database is currently evolving. Modern vehicles generate automatic telemetry data and AI-driven analytics, feeding richer, immediate information straight into the system. But there is a heavy reality that separates FARS from standard enterprise systems. Its incredible precision is built entirely out of human loss. Of code, it captures painful lessons of the past, ensuring the next generation of drivers survives the trip home.